In this video, I want to look at an example of how we might go about showing a particular point is an accumulation point for a particular set. I want to look at problem 43 from the textbook. You should stop the video, copy this problem carefully into your notes, and you should spend at least a few minutes thinking about how you would approach trying to solve this problem. And even try and draw some pictures to convince yourself that the problem makes sense. And after you've done that, start the video back up and compare what your approach looks like to mine. So hopefully you've done that. What I want to do is I want to start by writing down what I know, and I want to write down what my goal is, and I want to continue illustrating stuff as I go through things. So what do I know here? Well, I know that O is the open interval between A and B, and I can certainly draw that. So there is my number line, and here is A, and here is B, picture of O. And I know that P is inside O. So I'm going to put P somewhere inside this interval. I'm going to put P right there. And I want, and let's get a different color out for this, I want to show that P is an accumulation point for the set O. Now I have to think about what that means. So I want to show that this is an accumulation point into what it is that we actually need to do. Well, we have to use the definition. And the definition of accumulation point says that what we need to do is we need to show the following. If O hat is any open interval containing P, then there exists an X inside O hat such that X is also inside O, that should be an O hat, and X is not equal to P. That would mean P is an accumulation point for O. So this will say P is an accumulation point for the set O. Now I have to think about what does this actually mean, and I'm going to kind of clutter this up for just a minute, and then we'll step through this one step at a time. Basically what I want to show is that given this picture, no matter what open interval O hat, and I don't know, I'm going to look at an O hat that maybe looks like this, so that's an O hat. Or maybe my O hat looks like this, or maybe my O hat looks like this, or my O hat looks like that. But somehow with one of these O hats, I have to be able to always find an X inside the green interval that's also inside the yellow one. So I want to think about how I'm going to do that. I'm going to look at what I know, and then I'm going to look at what I know about O hat, and I'm going to then put that together, and that will let me solve the problem. So let's see, what do we know? I know that P lives inside the open interval A to B. So here's my number line. Here's A, here's B, and here's P. Now this tells me that there exists a delta 1 such that the delta 1 ball centered at P is a subset of AB. And I'm going to draw that delta 1 ball. So here's a delta 1 ball. So this is BP delta 1. And that's one of the things that I simply know. Now what I'm going to do is think about what else I want. I'm going to be thinking about this. I'm going to let O hat be any open interval containing P. So I'm going to draw another number line. There's my green number line. And I don't know, O looks something like this. And I have no idea where P is, but P is somewhere in here. So maybe P is there. And because O hat is an open interval that contains P, what I do know is that there exists a delta 2 that's bigger than 0, such that the delta 2 ball centered at P is a subset of O hat. So that would look something like this. This is my delta 2 ball. Now I'm going to let delta be the smaller of delta 1 and delta 2. And so basically I'm going to look at this ball, and I'm going to look at this ball, and I'm going to select the smaller one of these two things. So what I want to notice then is, what does this actually say? So the delta ball centered at P is going to be a subset of the delta 1 ball, and the delta ball centered at P is going to be a subset of the delta 2 ball. Well, this is going to tell me that my delta ball is actually a subset of my original O interval, which is the interval between A and B. So X inside this ball does imply X is inside my open interval between A and B, which remember is set O. But what about this side? This is going to imply that my delta ball is a subset of the arbitrary open interval O hat. And that's going to tell me that X inside my delta ball will imply that X is inside O hat. And we're almost done. The only thing that we have to do is we have to make sure that there's an element inside that delta ball that's not equal to P. So I'm going to draw the picture one more time. What I know is I've got, let's make this number line a different color. We've got a number line here with P. Sitting here in the middle, and we have this delta ball. And this delta ball is a subset of both the original interval, and this delta ball is also a subset of the new open interval O. And obviously inside of a delta ball, there's lots of elements that are not equal to P. Then that implies X is indeed inside my original interval, and X is inside my new interval, and because I chose X not to be equal to P, X is not equal to P. So to write a conclusion, every open interval that contains P also contains at least one element of my original open interval, the interval from A to B, that is not equal to P. And that's enough to say P is an accumulation point for the interval going from A to B. And that ends the proof.